அது உங்களுக்கு தான்.
எல்லாருக்கும் உண்டாது. இந்த ட்ரைனிங்
அதான் தெரியும்.
Triangle will begin in 0 seconds.
So, you want to take over control. You all look like rookies to me. Running a power station takes years of training. Just look at this control panel. I wouldn't recommend touching anything on this panel unless you knew exactly what you were doing. But then again, my first day, no one let me touch anything. So maybe with my guidance, you'll do okay. Let's start with a warm-up question. How much electricity do you think the power station could produce at full power? Use the switch on the screen to make your choice. Turn the knob to the answer you think is right. You've got 5 seconds to answer. If you answered 75 megawatts, you're pretty close. This station was licensed to produce 76 megawatts, or 100,000 horsepower. Actually, at full capacity, we could produce 120,000 horsepower. That's enough to power over 30,000 ovens at the same time. The point is, people who worked here were working around some incredible power. The power was constantly flowing out of the station and into the main power grid to power real factories and homes. Do you see this piece of equipment here? This is a synchroscope, and it was a key piece of equipment for getting power safely onto the grid. So what do you think a synchroscope measured? Did it measure time or power? Or sync me? I'll give you 4 seconds to answer. If you answered sync or synchronization, you're correct. A synchroscope tells you when the power being generated is synchronized with the entire electrical system. So what do we mean by in sync? Think of it this way. Imagine playing a game of double dutch jump rope, and it's your turn. You don't just rush right in, no. You watch the ropes and you get yourself in sync. Then you jump in. Moving electricity onto the grid is similar. We had to get the power we generated in sync with the main grid. First, some basics. For a generator to generate power at the right frequency, the rotor inside the generator had to spin at exactly 250 rotations per minute. And the speed of the rotor completely depends on the speed of the turbine rotating below. So adjusting the speed of the rotor meant adjusting the flow of water. And for that, we had a clever piece of equipment called a flyball governor. Try to follow. There's a gear on the main shaft that was linked to the flyball governor. So as the shaft spun, these heavy flyballs would spin too. The flyballs were also linked to a valve far below that controlled the flow of water hitting the turbine. Now if the generator was spinning too fast, the flyballs would rise higher, closing the valve a little bit and slowing down the turbine. If things were spinning too slow, the balls would droop down a little, opening the valve and speeding up the turbine. Like I said, a clever machine. But it also took some fiddling to get the thing exactly in sync. The way you'd know if you were in sync was with the synchroscope. The black needle is telling us if there is any difference between the electricity in the grid and what our generator is producing. When the needle stops rotating and holds steady near 12 o'clock, that's when you're in sync. A really skilled operator would get the needle moving really slowly towards 12 o'clock. And then just before it was pointing straight up, throw the switch to move the power to the grid. Got it? Good. So here is your final test. On your screen,